Hello everyone. Today I'm going to talk about part of my research, which is about optimizing the circularity of electric vehicle batteries through shared logistics and the usage economy. At first, I'm going to talk about the agenda of today's presentation. I'm going to start with the motivation and context and then problem definition. And after that, about the research gaps and objectives, about our proposed approach and results. And at the end, I will conclude the presentation. Firstly, just you can see two graphs, and these two graphs, it shows the popularity of electric vehicles here in Canada. And the ones I mentioned here, that's about the popularity of electric vehicles in Quebec. As you can see, that's the majority of people use electric vehicles, and the popularity of that increased rapidly. That's a very good one because that is relating to the goal of zero emissions. But if we want to consider electric vehicles completely sustainable, we should consider about the electric vehicle batteries too, because they can pose some problems. Usually the lifespan of electric vehicle batteries that is shorter than the electric vehicle itself. And after when SOH of the batteries, I can show it here, when SOH of the batteries, which is the health of batteries that is under 70 or 80%, they lose their electric life. But they are still valuable because they contain critical raw materials such as lithium, nickel, and cobalt. And based on data by 2030, around 12 million electric vehicle batteries will going to be discarded, but they are still valuable. We can use it in less demanding applications as the second use, such as electric boats or electric bikes. And after that, when SOH that is under 70%, we can recycle them in order to recover the raw material. So before understanding the electric vehicle batteries, we should learn about the closed loop supply chain of batteries. So the forward logistic, it starts with mines, which is the extraction of raw material. And after that, we have electric vehicle battery manufacturers, which three main actions happen, such as cell production, model assembly, and pack production. And after that, we have OEMs and EV users. After EV users, instead of discarding the electric vehicle batteries, they go to the collection centers. And based on their SOH, they can be divided into different parts. For example, we can reuse them or we can repurpose them, as I mentioned, in less demanding applications, or we can recycle in order to recover critical raw materials. And now we consider some problems in that closed loop supply chain. The operation costs are usually really high, and the actors I mentioned earlier, they lack of coordination between them. And also, when electric vehicle batteries return, the uncertainty that's really high. In order to solve this problem, we consider in two different ways. The first one, that's about from a business model perspective. Based on literature, there are circular business models that well developed, but they don't consider usually the coordination among the actors. And another one, there is lack of quantitative validation for business models. And then from the optimization model perspective, again, there is a limited ability to incorporate collaboration among multiple actors. And of course, shared use of logistic infrastructure is rarely considered. So in order to just fill these gaps, we consider 5 different objectives. The first one, that's about we should consider the multi-stakeholder collaboration into reverse logistic systems. And then the second one, for any innovation, we need the business model. So we define the user-oriented business model that can create the quantitative framework. And after that, because in order to solve the lack of collaboration among actors, we try to implement sharing economy, and at the end provide a tool in order to have the decision support inside. So For implementing the reverse logistics, we should consider the electric vehicle battery waste hierarchy. As you can see from the bottom to the up, that is more circular, which is our goal. The green phase, that's about the pre-use, that's about the pre-design, that's mainly about preventing the using the lithium. So the best option that's using sodium instead of lithium. After that, we have the use phase. As I mentioned earlier, we have options such as reuse, repurpose, and remanufacture. And at the end, we have recycle and energy disposal. And the least preferred one, that is the landfill. So for in this case, we define the share reverse logistic, which is the combination of sustainable business models and reverse logistics. And with this share reverse logistic, we somehow can create the collaboration among actors, because we define some options such as transportation sharing or facility sharing or use parts sharing, and we consider some KPIs. They are triple bottom line, economic KPIs, environmental KPIs, and social KPIs in order to assess that. So as I mentioned earlier about share reverse logistics, in electric vehicle batteries, we consider two sharing economy options, which is about the battery swapping stations, and the next one that's about battery as a service. Here I can explain about this one better. The whole goal is we should shift from the ownership to access one. For example, in battery as a service, you can pay per use battery or subscription based battery. And in battery swapping stations, you can go and receive the full charge battery, and it can handle the thermal management of the SOH in a very good way. And another advantage of the battery swapping station, it can enable, it can reduce the charging time. So for having that decision is some tools in order to consider these scenarios. We use the mathematical optimization model with two main goals, which is the maximizing the economic and then minimizing the GHG emissions. So for the first goal, we consider some cost and of course the revenue. So the first one, that's the revenue. In the closed loop supply chain I defined earlier, the revenue, it talks about the new batteries, new recover batteries, and of course the new recover raw materials which gain from the recycling. Of course, it can have some costs such as fixed cost, shortage, or reverse logistic, or forward cost, and inventory cost. For our second goal, which is minimizing the GHG emissions, we consider the transportation and the GHG from the electrician activities. So at the end, about the conclusion, it shows that the best option, that's about battery as a service, that it can increase around 11% of the economy and 4 times increase the recovery of batteries. And the middle one, that's battery swapping stations. And we have 3 scenarios, which one of them, that is about the baseline. There is no sharing or collaboration among actors, which is the weakest one among the other ones. So we can understand that ownership-based models, that it acts better than infrastructure sharing, and then with no sharing. Okay. And I want to conclude with this picture that the future is not just electric, it's circular and shared. Happy to answer any questions, and thank you for your attention.
Okay, thank you, Aysan. I'll translate the questions for you if you want.
Ah non, c'était pour faire une traduction de la présentation.
Traduction de la présentation?
Ben, je vais essayer.
Go,
Il reste 5 minutes. Est-ce que quelqu'un veut?
Tout le monde a compris ou ça?
C'est pas nécessaire, ok, c'est bon.
Ouais, parce que là, moi, je m'embarque pas dans les batteries électriques, là.
J'avais pris des notes.
Et ça, c'est hors de mon cercle d'expertise.
Non,
oui, donc, est-ce qu'il y avait des questions? Vas-y, Andrew.
Thank you for the presentation. When we talk about changing to batteries as a service or the shared services, and I may have missed it, do you consider the behavioral changes that would be necessary for the consumers to accept that model?
Here you talk about the, can you just, because I can't hear you properly.
Yes.
But
When you talk about the battery as a service, do you consider in your research the cost or the implications for the customer to change its behaviors?
So, okay, thank you for your question. Based on the battery as a service in optimization model, we define three criteria, which is the active batteries, and then the ones that the subscription that is end, and the other one that subscription that is a start. That is three variables we consider in this scenario. Is it your question?
I asked the question because my father would not want to trade his car battery. So that's what I'm asking. A consumer who doesn't want to lose control of their battery is a real behavior change. So I'm just curious if you've thought about that.
Okay.
So there's no in your research, there's no element of the behavior of people. Is that
No.
what? Okay.
No, in the mathematical model, we don't have anything like that. But in terms of the when we don't consider it from the just decision support tool, when it's not quantitative, but in terms of the qualitative, as I mentioned here, in TBL approach, we consider three criteria. That in social KPIs, just we consider the behavior of the users too, but that is quantitative. It's not qualitative here. We just define the behavior here in social KPIs.
Okay, but they're quantitative social KPIs. So it says, je sais pas si tout le monde voit, mais it says social impact indicators is a number of new jobs, number of community engaged members, and number who gained access to resources, but there's no elements on behavior.
This is about the quantitative ones, but here, because we just have two goals that's relating to the economy and environment, we don't consider social here. But maybe it's future work, we can consider the behavior of the users as the qualitative objective too.
Okay. Est-ce qu'il y avait d'autres questions? That's the question.
ça peut être en français. Les
Ah ouais, les questions peuvent être en français. Je vais faire aller ma traduction automatique. L'intelligence non artificielle, parfait. Okay.
J'en ai une. Sorry, what is OEM?
That's about EV here. Thank you. That's
electric
OEMs.
Yeah.
That's about EV manufacturers. Original equipment manufacturers.
What's the original electric manufacturer? Equipment. Okay, thank you. Sorry, I'm my field of expertise.
Parfait. All right. Thank you, Aysan.
Thank you for listening.